Here we have the collector. These black containers you see here are called tanks, and they collect the balls after they finish passing through the rest of the clock. If the top tank is not full, then the balls coming in will fill it up. If the top tank is full, then the balls coming in will be deflected by the top tank so that they go into the tank right below it. If the top tank is non-existent, then the balls coming in will go straight to the tank right below it. These tanks, by the way, are identical to each other, so if I swap them out, it wouldn't make a difference. Also, on each tank, there's a bit of material over here, which effectively allows it to hook onto the frame so that it doesn't just slide straight out of the clock. If I wanted to take the tank out of the clock though, I would have to lift it up to unhook that part, and then I can pull it out. Each tank can store 87 balls. Now since there are 2 tanks, that makes for 2 times 87, which is 174 balls. Each of those balls allows the clock to run for 4 seconds, so that makes for a total of 11 minutes and 36 seconds with those 2 tanks. Fortunately, however, I can make the clock run for much longer than 11 minutes and 36 seconds. And to do this, I simply have to wait for the clock to run for a little bit, and once some of the balls have made their way back to the collector, I can just take them and dump them right back up into the storage to go through the clock again. There's actually a special technique for pouring the balls from the tank into the storage. You see, I can't just pour it in like this, because then the balls start jamming against the tank. So I need to pour it in sideways like this. And I usually have a hand over here to brace the balls so they don't just roll out. So I pour them in like this. And then I just go ahead and put the empty tank back into the collector. I learned some pretty interesting things while I was designing this collector section. So I think the best way for me to share what I learned is to walk you guys through the design process that I went through. Here was my first design. It was meant to have all of the functionality as the current design in the background over there. But as you will see, it had some pretty serious flaws, and I'll go ahead and show you one of them right now. So basically the balls are just lining the bottom part of the tank, but they aren't filling up all of this space over here, which is obviously a pretty significant flaw because I'm trying to store over 100 balls, and this is clearly not going to cut it. To solve this problem, I realized that after the first layer of balls had been laid down, I needed for any subsequent balls to not get stuck over here, but rather to roll all the way down until they reach the end. That way, the second layer can be completely filled up, and once that's completely filled up, then any balls coming in will roll all the way to the back and start the third layer, and so on and so forth until the entire tank was full. Well, this requires that the tank be inclined a bit, so I had to figure out which angle was optimal for doing that. To solve this, let's imagine that this is the bottom of the tank, and these are the balls on the first layer. Now, I've just added another ball onto the second layer, and I wanted to roll all the way down. Well, to do this, I first need to realize something, and it's that if I have one ball directly on top of the other, such that if I connect their centers together, this dashed line here will be vertical, then this top ball will always roll off of the bottom one, because this is essentially unstable equilibrium. If I give the top ball even the slightest nudge, then it'll roll off. So I'm going to try to do something similar here. Imagine that this ruler is a vertical line, and it's in the same direction as gravity. And I'm going to go ahead and connect these 2 centers with the dashed line. I want to be able to rotate this entire setup enough so that this ball is right on top of the one below it, and it's pretty much guarantees that it's always going to roll down, because given the slightest nudge, it will roll down. So that angle by simple geometry is just 30 degrees. So if I angle this by 30 degrees, it will guarantee that any ball I add is going to roll down. However, 30 degrees is a lot because if I incline the tank by that much, there's a lot of empty space here that's going unused. And also, it increases the overall height of the tank and therefore the collector, because originally it was like this, but then I increased the incline and therefore increased this overall height. Turns out I can do better than this. I can actually make this work with just a 15-degree incline. To explain why, let's go back to this drawing. So instead of inclining it by 30 degrees like this, let's go less than that, so 15 degrees. Now it is true that if I were to place this ball gently into this groove over here, it would come to a rest and it wouldn't roll down this line of balls. But if I were to give this ball enough of a nudge to push it over the one below it, then once that ball starts falling into the next groove, it has enough momentum to carry it over the one after that, and the one after that, and so on and so forth. So it turns out that I only need a 15-degree incline to cause the balls to roll down here, because usually when they land over here, they already have a bit of horizontal velocity to pull them over the ball below them. Here's a close-up of the process. It's probably not surprising that in the next iteration of the collector, I angled the tank by 15 degrees. But there was still an issue because once the first layer of balls was laid down, when I try to put another ball in there, sometimes it would get stuck in the grooves over here. Let me just move it closer so you can see. It would just get stuck in these grooves and it'll have difficulty rolling down. So I solved this in the third iteration. And all I really did was I aligned these railings to be parallel to the lines of balls rather than perpendicular to the lines of balls. I made some minor improvements going from this third iteration to the fourth iteration, but there was still one issue because this works most of the time, but sometimes when this tank is almost full, then the incoming balls don't have that much horizontal velocity right when they land, so they just end up going right over here. And this is an issue because when I have that, then the next ball is going to go ahead and hit that, and it's going to end up not going into this tank. So in effect, I end up having a ball bypassing this tank before it's full. Before I continue though, let me explain why I want this top tank to be completely full before it starts deflecting balls to the lower tank. So in this situation here, the bottom tank is already completely full. So if this top tank ends up deflecting some balls to the lower tank, it's just going to cause it to overflow, which is obviously an issue. And this isn't the only reason why I want the top tank to be full before it starts deflecting balls to the lower tank. There are other reasons, but this is an example of one of the more significant reasons why. Turns out solving that problem really wasn't difficult at all. So in this tank, the flawed tank, this section over here is straight. Well, in the next iteration, all I had to do was add this bit of material over here so that it wasn't straight anymore, and I pretty much solved the problem completely. It's hard to show you why using the physical models, so I'm going to go ahead and use the CAD model. So here's the collector. Let's go ahead and cut it in half. And then let's go ahead and go into orthographic view. Okay, focus in on the top tank here. Imagine that it's partially full, so that these 4 layers here are full, but the 5th layer is empty. Now, the display section is right above the collector section, so imagine that there's some more balls that are about to go into this top tank here. So with the previous straight track design, this orange ball could potentially come to a rest on top of the blue ball like this, and this is bad because the green ball can come in and end up deflecting off of the orange ball, going into the lower tank before it's supposed to. So because of this bit of material over here, now when the orange ball comes in, the best I can do is be right on top of this blue ball. And we know from the previous drawing that this is an unstable position to be in, so the orange ball is going to roll down, and once it starts rolling down, it's going to keep rolling down until it goes down all the way. And then when the green ball comes in, it's going to go ahead and do the same thing. And if there are any more balls, they'll keep on doing this until this top tank is full. So there you go. That's basically how I got to this current collector design. And one of the recurring themes I've noticed throughout this project is that every detail matters, and this collector section was definitely not an exception.